Hi, Algebra 2. Welcome to our first video lesson. What I'm going to be talking about today are squares and square roots. And so you guys already have some familiarity with those. They're pretty much opposites of each other. So just to take like a really basic example, we know that what 7 squared means is to do 7 times itself. So 7 times 7 makes 49. Okay, so that's what squaring is. The opposite of squaring is to take a square root. So like an opposite problem would be, if 7 squared is 49, I could ask, what is the square root of 49? And all a square root is asking is, what number multiplies by itself to give you this number? So you'd be like, oh, like I know that 49 is 7 times 7, so the square root of 49 must be 7. And this works for anything. So if I was to tell you that like 11 to the second power is equal to 121, you would know in return that the square root of 121 had to be 11. Squares and square roots are opposites. A square root is just asking, what number do you multiply by itself to give me this number? Okay, so where does this get tricky? This gets tricky when we have numbers that don't have an exact square root. So a great example of that would be the square root of 50. The square root of 49 is equal to exactly 7, because 7 times 7 makes 49. The square root of 50 is a little tougher because there is no number that you could multiply by itself to get exactly 50. And so there's two options here. When we get a square root that we don't totally know, one option we have is to get an approximate value for it. And you can actually never get an exact value because it's a decimal that goes on forever and ever and ever. But we can actually ask our calculator, if you look above your x squared button, you have a square root button. So if I hit second x squared, I'll take the square root. If I take the square root of 50, my calculator tells me that that's about 7.07. So if I'm rounding to the nearest hundredth, just keeping 2 digits after the decimal, it turns out that the square root of 50 is really, really close to 7.07. So 7.07 times 7.07 gives you something really close to 50, which makes sense because 7 times 7 makes 49. A little bit more times itself gives you 50. The other thing that we will sometimes do when we have a square root and we don't know how to work with is we'll do what's called simplifying the square root. And simplifying the square root is basically looking to see if there's anything you can pull out from under it. So usually there's kind of a smart way to break the root down so you can yank some stuff out. In this case, it turns out the square root of 50 could be written as the square root of 25 times the square root of 2. Now, why is that the smart way to break it down? Well, because I know the square root of 25. 25 is a perfect square. I can say that 5 times 5 makes 25. So this becomes 5 times the square root of 2. And that's considered the simplest version of the square root of 50 because I've sort of pulled out everything I can. Now, what I'll say is a lot of people sort of don't like finding this like magic combo of numbers, and what a lot of you guys might be used to before is making a tree diagram. So you could be like, oh, 50, that's 5 times 10, and 10, that's 5 times 2. I find the prime factorization of the number. If you look at a root that has underneath it 5 times 5 times 2, there's this little trick that whenever you have two numbers that match underneath a root, you can pull that out to become one regular number. So like the square root of 5 times 5 is 5. This becomes 5 on the outside times the square root of 2 on the inside. So a pair on the inside becomes 1 on the outside. 5 squared is 25, so the square root of 25 is 5. Okay, let's do another one like that. Let's say that I gave you the square root of 90. Again, I don't know exactly what that is. That's like a weird number. So one thing I could do is I could ask my calculator for the square root of 90. If you ask your calculator for the square root of 90, it gives you 9.486. So if I'm rounding to the nearest hundredth, if I'm keeping 2 digits after the decimal, that's going to round to 9.49. So it turns out that the approximation for this is about 9.49. 9.49 times 9.49 gives me something really, really close to 90. If by contrast I wanted to simplify the square root of 90, Probably my best bet is to make a tree. So I can say 90 is 9 times 10. 9 is 3 times 3. 10 is 5 times 2. So if I look at the prime factorization of 90, I am looking at the square root of 3 times 3 times 5 times 2. Anytime you have a pair on the inside, that can become 1 on the outside. So the square root of 3 times 3, the square root of 9, just becomes a regular 3. Everything left together just gets multiplied together. So the inside is going to become the square root of 10. Square root of 90 is about 9.49. The exact value is 3 times the square root of 10. Okay, so now that we know how to take a root and simplify it, we're going to do some problems where we multiply roots together. So I'm going to erase all of this. Guys, you know what I like about the fact that we're making tree diagrams for our roots? Is it allows us to spend some time with trees, and I love trees. I hope you guys have managed to get some time outside in the trees during our days apart. So like I said, we're going to multiply roots together. What's cool about multiplying roots is you've got options in terms of your order. So here's what I mean. For example, let's say I asked you to do the square root of 9 times the square root of 4. It actually doesn't matter whether you multiply the numbers together first and then take the square root, or take the square roots first and then multiply. They both work. So for this one, I actually know the square root of 9. The number that multiplies by itself to give me 9 is 3. I actually also know the square root of 4. Number that multiplies by itself to give me 4 is 2. So one thing I can do is take the square roots first and then multiply. 3 times 2 makes 6. But it's also totally fine to first multiply the numbers together and then take the square root. By which I mean I could figure out what is 9 times 4 and take the square root of that. I actually know that 9 times 4 is 36. And so then this question is just asking, what number do you multiply by itself to give you 36? The square root of 36 is equal to exactly 6. So as you can see, it doesn't matter which order you follow. You can multiply first and then take the square root, or you can take the square roots first and then multiply. Sometimes you will have a problem where the order is kind of matters. So for example, let's say I asked you, what is the square root of 2 times the square root of 32? I do not know the square root of 2. It is like 1.4 something and it goes on forever and ever and ever. I do not know the square root of 32. It's like 5 point something and it goes on forever and ever and ever. I can't start by taking the square roots because I do not know them. But what I can do is I can say, well, why don't I just multiply these numbers together? So 2 times 32 makes 64. And even though I don't know that square root and I don't know that square root, I do know the square root of 64. The number that multiplies by itself to give me 64 is 8. This is one of these rare, beautiful problems in math where I had an extremely disgusting number with a decimal that went on forever times another extremely disgusting number with a decimal that went on forever, and together they multiplied to make something really, really nice. That is a rare and beautiful moment when sort of a weird number finds another number that's weird in just the right ways so that their product is really nice. The product won't always be nice. You'll have to forgive me. Sometimes you'll have a problem where things are a little gross. So for instance, you could have like the square root of 3 times the square root of 6. I don't know the square root of 3. I don't know the square root of 6. Those are both really gross. But I can at least multiply 3 and 6 together. So 3 times 6 makes 18. Here's the annoying thing. I don't know the square root of 18. The square root of 16 is 4, but I don't know anything that multiplies by itself to give me 18. That's okay. If you get to something and you don't know exactly what it is, just simplify it. So I'm going to say, I don't know the square root of 18, but I can make a tree for that. That's 9 times 2. So that's 3 times 3 times 2. And I can just use my same rule as before. A pair of numbers on the inside is as good as a regular number on the outside. So 3 times 3 makes 3. This becomes 3 times the square root of 2. And you're all done when you get there. There's no more simplifying that you can do. Okay, so sometimes these problems will get a little bit more complicated. They'll have like some extra numbers in them. So let's do a little practice with that. All right, so for example, let's say that I asked you about 2 times the square root of 5 times 7 times the square root of 20. All right, so that problem looks a little bit more intimidating, but there's some easy tips you can follow. You can always multiply a regular number times another regular number. So like regular 2 times regular 7, that's just going to make regular 14. And then you can always multiply a number under a root times another number under a root. So 5 times 20, that makes 100. This problem is actually great because I know the square root of 100. The number that multiplies by itself to give me 100 is 10. So this is 14 times 10. The answer to this question is exactly 140. 2 kind of messy numbers that multiplied together to have a really nice answer. Ooh, that's right in the glare. Here, I'll tip it up for you guys. 140. All right, let's do one more like that. Suppose that you had a question like 3 times the square root of 21 times 2 times the square root of 15. Regular number times regular number. 3 times 2 makes 6. Root number times root number. Ooh, 21 times 15. I don't know what that is. Here's the good news. If you have a number underneath a root and you don't want to multiply it, you don't have to. Because all we do underneath the root is like make a tree of everything and pull stuff out anyway. So if you have 2 numbers you don't want to multiply, don't. Just make a tree right away. 21 is 7 times 3. 15 is 5 times 3. I can literally just write that this right away becomes 6 times the square root of 7 times 3 times 5 times 3. A pair on the inside becomes 1 on the outside. So basically 6 is already chilling outside. 3 is going to come to join it outside. 7 and 5 are left underneath the root. And everything gets multiplied times whatever it's near. So 6 times 3 multiplies to make a product of 18. 7 times 5 multiplies to make a product of 35. So this kind of gross problem becomes 18 times the square root of 35. Okay, I got one more thing to show you guys really quickly. And that just has to do with the fact that squares and square roots are opposites of each other. So what that means is whenever you have a problem like, what is the square root of 16 squared? You don't have to do any math. You can just say, I know that square roots and squares are opposites each of each other. Squared and squared cancel. This would just give you an answer of 16. Now you can prove that that's the case. You can say the square root of 16 is 4. 4 squares to make 16. But you don't have to do that. It turns out that whenever you have the square root of something squared, you can just cancel out the square and the square root. Boom, this just gives me 49. So if you want a general rule for yourself, you can say, in general, any number, if you take the square root and then you square it, they cancel each other out and you just get back to the number you started with. It's really, really nice. The only other type of problem that you guys are going to see that I want you to be able to do is if you're asked to square something that has a regular number and a root number. So an example of that would be something like 2 times the square root of 3. For a problem like this, if you are squaring that, just make sure you square the front and the back. So you're going to have 2 squared times the square root of 3 squared. 2 squared makes 4. The square root of 3 squared makes 3. I have 4 times 3. My final answer is 12. Good luck, everybody!